Welcome back to Fleet Insider, Episode 3. If you run a modern commercial fleet, you absolutely know video is essential. It's really your best defense for safety, for compliance.
Yeah, it really is.
But let's be honest, right? Those agonizingly slow video offloads, they can crush efficiency, waste so much valuable staff time. It's frustrating.
Oh, absolutely. They really are. I mean, think about it. You're dealing with gigabytes, just
Yeah.
huge amounts of data from multiple cameras, maybe across dozens, even hundreds of vehicles.
Right.
And waiting for those wireless transfers, it just becomes this catastrophic bottleneck.
Yeah.
So today, we're diving into why those offloads take forever and, maybe more importantly, what technical fixes you can actually use to speed things up.
Exactly. And our mission here, it's really about connectivity and, well, physics. This whole fleet video offload thing, getting huge files off the vehicle, it hinges completely on wireless connections. Wi-Fi, LTE, 5G, you name it.
Which makes it an upload speed problem, fundamentally.
Precisely. And what controls that speed often isn't just about how many bars you think you have. There's more going on.
Okay, let's unpack that. Our sources kept pointing to three key factors, often invisible ones that really dictate speed and reliability. First one's one we all recognize, signal strength.
Right. This is your RSSI, the received signal strength indicator. Think of it like the volume knob for your connection.
Volume, okay?
Yeah, it's just measuring the raw power of the signal reaching the device. It's your basic bars on the screen. Generally, more power means potentially better speed.
Simple enough. RSSI is volume. But factor two, signal quality. You mentioned things get invisible here. This sounds like the real gremlins sometimes.
It often is. Signal quality deals with interference. The sources talk about RSRQ, reference signal received quality.
RSRQ, okay.
Yeah, think of RSRQ like static on a radio. You can have the volume cranked way up, that's good RSSI.
Yeah.
If there's tons of static, terrible RSRQ, your actual data transfer speed just plummets.
Why is that?
Because the system keeps having to resend data that got corrupted by the noise. So a clean signal, low noise, low RSRQ actually, means a much more stable, faster transfer. It's a bit counterintuitive.
Right. So high volume is useless if the line is full of static.
Got it.
Okay, that brings us neatly to factor three, network bandwidth utilization.
Exactly. This one's more straightforward. It's just traffic jams, network congestion.
Other devices hogging the line.
Pretty much. Could be other trucks nearby, maybe even non-fleet stuff sharing the network at the depot. If that network connection is already heavily used, your video offload share just shrinks. High use equals slowdowns. Painfully long waits sometimes.
Okay, strength, quality, congestion.
Yeah.
Understanding those really sets the stage for, well, the big decision every fleet manager faces. Video resolution.
Ah, yes, the file size dilemma. It's central. If you're prioritizing high-resolution video, maybe for detailed incident reviews, compliance, that sort of thing,
You need that clarity.
you do. But you're dealing with massive files. Even if your connection is perfect, strong signal, clean line, no traffic, you're probably looking at a 1-to-1 offload ratio.
Meaning a 30-minute video clip takes 30 minutes to transfer.
Best case, yeah. But if speed is the absolute priority, say for real-time alerts or live streaming,
Then you go low resolution.
right, the files are much, much smaller. You could potentially hit a 2-to-1 ratio. That same 30-minute clip might transfer in 15 minutes, maybe even less.
So clarity versus speed, what's the best practice then? Seems like you need both.
Well, the sources really lean towards a hybrid model. Use that high-res footage for your recordings, your evidence locker essentially, but use low-res specifically to support live monitoring and those instant alerts.
So you get your forensic detail and your real-time capability. Okay, that makes sense. But let's get really practical. Say I need that high-res clarity for potential incidents, but I absolutely have to cut down that transfer time. What's the single biggest technical lever I can pull to shrink the file size without, making the video useless?
The main thing, and it's often overlooked, is adjusting the frames per second setting, your FPS.
Lowering the FPS, wait, isn't that risky? If I lower the frames per second, don't I risk missing the crucial moment in an incident? That seems like the whole point of having the camera.
That's a fair question, and it's critical. But here's the thing. Lowering FPS reduces the quantity of data per second, not necessarily the visual quality or resolution of each frame. So dropping from, say, 30 FPS down to 15 FPS, it dramatically cuts the file size and upload time. But for almost all compliance needs, 15 frames per second is usually more than enough to capture the event clearly. You still see what happened.
So you don't really lose the critical detail for reconstruction.
In most scenarios, no. You maintain the resolution, but significantly reduce the data load. It's about minimizing data without compromising the actual evidence value.
Okay, so optimize the connection, manage that RSSI versus RSRQ balance, watch for congestion, use the hybrid resolution model. And maybe the most powerful tool is tweaking that FPS setting.
Exactly. When you put it all together, optimizing fleet video is really a balancing act, isn't it? Speed, clarity, those connectivity factors, and then smart file size management like FPS.
Absolutely.
That's a great point to end on. Thank you for tuning in to Fleet Insider Episode 3. We really hope this has given you some new insights to consider.
Thanks for listening, and we'll see you on the next one.